Okay, so let's take a look at how we can manage state in Effect. Now, Effect offers three different solutions for state management. We have Ref, we have SynchronizedRef, and we have SubscriptionRef. So let's start with the most basic one, the foundation for the others, and that is simply Ref. Now, if you take a look at the documentation, it really has most of what you need, but I'll show you how all of this looks like in the source code. However, there's just one thing I'm not a fan of, and that is how it oversells Ref. It makes it seem like it is way more powerful or perhaps complex than it actually is. For example, it says, in traditional imperative programming, one common way to store state is using variables. However, this approach can introduce bugs, especially when the state is shared between multiple components or functions. As the program becomes more complex, managing shared state can become challenging. To overcome these issues, Effect introduces a powerful data type called Ref, which represents a mutable reference. With Ref, we can share state between different parts of our program without relying on mutable variables directly. Instead, Ref provides a controlled way to handle mutable state and safely update it in a concurrent environment. Effect's Ref data type enables communication between different fibers in your program. And this is what I'm talking about. Now, this is factually correct, but again, it is overselling it a little bit when in reality, it is simply a basic wrapper around a let variable. It doesn't particularly solve anything regarding concurrency. It doesn't prevent race conditions. So that's why I'm not a fan of how they word this. And it is also a little bit too vague. Now, we do have SynchronizedRef, which solves the concurrency part, which helps you prevent race conditions, but we are in the page of Ref, not SynchronizedRef. And additionally, Ref isn't the one that really enables communication between different fibers in your program. If you want to communicate or share state between different fibers, well, you can use a global let variable. Or if you want to maybe localize it to a particular context, then you would use Effect's context for that. So again, Ref itself isn't the one that enables the communication between different fibers. Anyway, enough talking, let's take a look at how we can use it. So for that, I opened Effect's playground, and what I'm going to do is simply import Ref from Effect. Now let's say you want to have a counter. Well, for that, you know that you can do let counter is equal to 0. But if we're going to be using refs, we can say counter ref is equal to yield ref.make. And then here we pass in the initial value. And well, this is generic, of course. So we can specify the type here explicitly if we want. Now this is going to give back to you a reference holding a number, as simple as that. Now the make constructor returns an effect that succeeds with a ref, does not fail with anything, does not require anything. Now here you might be wondering, why is the constructor an effect if ultimately it is merely a simple wrapper around let? Well, that's true. If you take a look at the source code for ref, which we're going to do in a moment, you'll see that it doesn't have anything asynchronous, and well, it really doesn't require anything effectful. But the reason for that is because we have SubscriptionRef and we have SynchronizedRef. And these two internally need some additional stuff from the core of Effect or the concurrency we were talking about. So I guess to make the API as consistent as possible, so if you are going to be using Ref and then you want to use SubscriptionRef, then it is not going to affect the flow of your program because it has a universal exposed API. Anyway, with this, if you want to get the value, again, it is going to be an effect. So we have the get property, and as we can see, this is simply an effect that succeeds with the current state in this ref. And why an effect? Well, again, SubscriptionRef and SynchronizedRef need concurrency stuff So it makes sense that it is universal across all implementations. So for this, you can say current value is equal to, and then we must yield this. And with this, we can come here and log the current value. And if I save this and then expand the terminal, as you can see, it is not logging anything. Now I'm not sure why the playground wasn't working. I'm using a Firefox-based browser nowadays, so it could be something related to Firefox, but anyway, if I run this locally, as we can see, we get 0. Now if we want to update the ref, then we can do counter ref dot, and then we have modify. Now this is like the more low-level API for the ref, where modify is a function, you get the current value, and then you must return a tuple. And why a tuple? Well, the first element of the tuple represents what you're going to be returning from modifying the ref. And the second element is the new value that you want to set to the ref. Now in a moment we're going to check why that is in the source code, but for now we can increment the value by 1, and then if we do this, as you can see, we get back a number. If we were to return undefined, for example, we're going to get back undefined. However, this is the new value that we want to set to the ref. So if I log data and then log not the current value because that is stale, but counter ref.get again, and then do this, as you can see, we start with 0, then we have undefined, but even though we have undefined here, notice how the ref was updated to 1. Now if you need higher level functions, you can say yield ref dot, and then here you have a wide variety of updaters, of utilities. So as you can see, you have update, then update and get, you have set here, you have the get here if you do not want to use the getter, so this one right here, and you have update sum and get, so this is for options. You have the unsafe make, and this is just a function, so as you can see, this doesn't return an effect. So in those edge cases where you're out of effect, maybe in the front end you want to initialize some global state, well, you can do that here with unsafe make, and that's pretty much it. So as you can see, it's just a wrapper. It has some utility functions to make your code a little bit more declarative. Now, one limitation of using ref is you do not have the ability to update the reference in an effectful way. That means that modify expects you to just return the tuple, not an effect that succeeds with the tuple. And well, that applies to update, for example. If we take a look at update, as you can see, the applying function must return a, not an effect of a. So what can you do in that case? Well, for that, you can use SynchronizedRef instead. If we change this, as you can see, everything still works. However, if we come here and do this, then we can say update effect. And now here we can pass in the counter ref, and then here we can do some asynchronous work. So for example, we can have a random sleep, which uses random from effect, and it is simply going to effect.zipWrite, effect.sleep, and not a zipWrite but a flat map, so that we have access to the result. And then we can say millis, and then here we can say random sleep, and then we can increment the value and return it here, which again is not possible if you just use update. So now it's time to look at the source code. Let's see what really differentiates ref with SynchronizedRef. So taking a look at the implementation, as you can see, it has a constructor and takes in a mutable ref. So this ref right here is indeed another wrapper for a mutable reference. Anyway, here it sets the getter. So as you can see, the get is simply a core.sync, so a synchronous thunk. As you can see, an effect that succeeds with a. Simply going to say mutable ref.get. And as for the modify, it takes in a function, and this function must return a tuple. And as you can see, this is just a synchronous computation. So again, core.sync, or well for us, effect.sync. And it is simply going to read the current value with mutable ref. Then it is going to apply the function by passing in the current value. And this is going to return to us this tuple, where b is the value that modify is going to return, while a is going to be the value that is going to be set to the ref. Now, as you can see, this has optimization technique, which is simply doing a strict comparison, checking if current is different from a. But well, if you're storing anything allocated in the heap, it is going to compare by reference. So 9 out of 10 times, this is of no use. However, it's nice that they included this. So now with this, we have everything we need to build the API. So we need to read the value, well, we just use get. And we need to modify the value, well, we can use this. As simple as that. So let's start. Unsafe make is just a new ref implementation, and then mutable ref.make with the value. So as you can see, it really doesn't have anything unsafe. It's not like using run sync on an effect when you know that that effect can be asynchronous. Well, this doesn't have anything of that nature. So this isn't really unsafe. This is just a function, a normal function. Now, as for the make, notice how it is simply a synchronous wrapper for unsafe make. So this now wraps it up in an effect. Now again, this really doesn't make sense. Why add effect in places where you really don't need effect? But again, the reason is for keeping a convention. All refs extend from the base implementation, so it's really nice that you can simply swap a ref for a synchronized ref, or a synchronized ref for a subscription ref, and you do not need to refactor anything. Anyway, the get is just self.get. So as you can see, if you recall this right here, very simple, again, an effect wrapper. And then we have the set. So notice how the set takes in self and then takes in the new value. And this is simply going to do self.modify, and it is going to return as the first element, so b undefined, and for a, the value that you pass in. So notice why it is using this tuple convention. The set is not a set and get. It is just a set. So that's why it returns undefined. So as you can see, an effect that succeeds with void. But well, the new value that is going to be set is this one right here, logically. Now we have get and set. As you can see, get and set is just taking in a, which is the new value, and returning that as b. And then the new value that is going to be set is this one right here. Now you have get and update, you pass in a callback, you do this, and it is going to return the new value. Then you have get and update sum for working with options. Then you have set and get. As you can see, simply returns the value that you pass in, and the new value is the value that you pass in, etc. As you can see, it is very, very simple, just a wrapper for let variables. Now let's take a look at SynchronizedRef. So here, notice how it starts working with effects. As you can see, core.map applies the function, gets the result here, and then the same tuple fashion. And as you can see, it is just all of the functions that we just saw, but with effect wrappers, so that you can have asynchronous stuff and whatnot. However, let's come here to the source for this, and that comes from circular, I believe. If I come here to unsafe make, notice how it uses circular.unsafe make synchronized. And if I come here, it creates a reference using the base reference, and then it creates a semaphore with only one permit. And then it wraps the ref with a synchronized implementation, and the lock is this one right here. So that means that when you create or make a synchronized ref, that instance will be the one that initializes the semaphore, and that prevents race conditions. So if I come here to the synchronized implementation, notice how it is pretty much the same. This .get is just internal ref.get, However, there's one difference, and that is this modify. This modify uses modify effect because again, it must use the semaphore, which is the only difference with the other ref. So here it takes in the same function, but instead you must return an effect that succeeds with the tuple, and then it does this dot with lock, so consumes the semaphore, protects this in basically a mutex, and then it is going to get the reference, it is going to apply the function, and then it is going to get the result here, and then it is going to set the value in the internal ref. And that's it. That's the only difference between the two. One is protected by a semaphore, the other one is completely raw. So every time it uses the modify effect, so here in SynchronizedRef, for example, update and get effect, it is going to do a modify effect. So all effectful mutations will be protected under this mutex, preventing race conditions. That way you can guarantee that every time you're reading a value and modifying the value in the ref, you're not going to get any race conditions whatsoever. You're always going to operate on the latest value. So that's why it's called a synchronized ref. So if I come here to the website, they have this example. They have a get user age. So imagine you're hitting a database, an API, whatever. So as you can see, it is going to be delayed. And here it is going to use SynchronizedRef.update effect. It is going to take in the sum of ages, and then this is going to return an effect, which again is an asynchronous effect. And it is going to get the user age, and then it is going to concat it with this age. Now, if you were to run this concurrently, so for example, effect.all, and then you have 4 tasks with maximum 2, so only 2 at a time, you're still not going to get any race condition. Because remember, this internally is going to protect this computation right here with a semaphore of 1 permit. So if this one takes a lot of time, the other one that is queued up will remain queued up. Doesn't matter how long this operation takes. So basically, when you need to prevent any type of race condition, then go ahead and use synchronized ref instead of ref. Now this is the page where I would add that concurrency safe stuff that they wrote in ref. I'm not sure if it's really appropriate for this section right here. Anyway, with this, let's move on to SubscriptionRef. Now SubscriptionRef in fact extends synchronized ref, but the only thing that it adds is a changes stream. So you can subscribe to any changes that occur to the ref, and you're going to get the values there. So it is basically going to use a pop sub internally in such way that in the modify effect that we saw in the source code, it emits the new change to the pop sub, and so all consumers will react to that change. And well, you know that in effect, you represent that via streams. And that's the only difference. So with SubscriptionRef, you have the race condition safety, so actual concurrency safety. And on top of that, you have a changes stream. So let's take a look at SubscriptionRef internally. So if I come here, as you can see, we have the implementation here, which takes in the ref, which again extends the base ref, and then takes in the pop sub and the semaphore. And again, this .get is just ref.get, same thing as synchronized ref, but the changes is going to read the value. It is going to flat map the effect. So it is going to get the current value here, and it is going to create a stream from this .pop sub. And then once it creates the stream, it is going to concatenate the stream it just created, which would have 0 elements here, with a 1 element stream that holds the current value. So as you can see, you're going to get the current value in the stream. Now the creation of this will be protected by the semaphore. So if you're creating these changes stream and someone is trying to update the value, then it is going to be queued up. due to creating the changes stream. And then it is going to unwrap it. So as you can see, it is going to take out the success of the effect into just the raw stream by mixing up the errors. So the errors of the stream with the errors of the actual effect, and same with the requirements channel. Now modify is the same thing as SynchronizedRef. It simply calls this .modify effect, but notice how modify effect is going to read a value, then it is going to apply the function, it is going to get b and a, then it is going to set the new value, then it is going to omit whatever this returns, which is just void, and replace it with b, so what we're actually returning from modify effect. And finally, it is going to do a zip left. So it is going to keep this result right here, but execute this effect right here, which as you can see is just publish the new value to this .popSub. And all of this will be protected by the semaphore. And that's it. That's everything. Everything still remains the same. So the modifies and whatnot will just use modify effect internally, which will emit the event to the PubSub and will likewise protect it with the semaphore. Now as for the make itself, well, notice how it creates the PubSub unbounded, so it can receive as many events. It is going to create the reference, and then it is going to make the semaphore, and then it is going to do new SubscriptionRef implementation, and that's it. Okay, so now let's test the SubscriptionRef. So for that, same thing, SubscriptionRef.make, we initialize it with 0, and then what I do is pipe over changes, which again, we know gives us a stream, and then we're going to tap into the stream and we're going to log the value. And finally, we're going to do a run drain, that means run the stream only for its side effects. So here we're not doing any changes, but we know that it internally will concat the PubSub stream with a one element stream that holds the current state. So we should get a log here. So if I run this, as you can see, we get 0. Now what about mutations? Well, if I come here and fork this, so fork scoped, so fork this into the scope of the effect, that means that when the scope closes, it is going to shut down the stream. We're going to do yield and then SubscriptionRef.update. We're going to add one value and then another value. And now we need to provide the scope. So we're going to say this will be scoped until this point, basically. And if I save this and rerun this, notice how we only got 2. Why is that? Well, that's because in effect, new fibers begin execution after the current fiber completes or yields. So that means that when you fork a fiber with, for example, fork scoped, it is not like creating a thread that immediately starts running in parallel. Instead, this will be packed into a fiber, and this fiber is placed in the scheduler's queue of fibers. But the current fiber, so the parent fiber, this one, continues executing immediately. It doesn't wait for the forked fiber to start. And this is intentional, this is not a bug. Now, I'm not an expert on effects scheduler or how it handles the concurrency internally, but I believe they use cooperative scheduling. So if you want to read more about the theory of this and whatnot, I guess you can Google preemptive scheduling versus cooperative scheduling, and you'll find a ton of information. So what can we do here? Well, we can yield this effect, meaning that we can make the effect voluntarily pause its execution and return control to the scheduler so that it can run other tasks instead. And for that, in effect, there are 2 different ways for you to do that. And one way is to simply do yieldNow. And as you can see, you can set a priority. But if I save this, clear this, and run this, as you can see, we get 0, 1, and 2. So again, we paused the execution of this parent effect and allowed the scheduler to run other tasks, this one being another task. And that's why we get 0, 1, and 2. Another way is to do sleep, and we can pass in, say, a second, and by doing this, again, it is going to pause the execution of this fiber, allowing this forked fiber to run. Anyway, enough talking about the scheduler. Let's move on to the last point, and that is using ref in different parts of a program. That means that you can share it, you can access it as context and whatnot. Now for that, what you can do is use effect context. And if you go to the documentation, they have this section here, using ref as a service. So here what they do is define my state using context.tag, and this is where context.tag is perfect for. You can check out my other video comparing context.tag versus effect.tag and effect.service if you're not sure what all of these things mean. And then here they say they're just going to hold a reference. So this is the shape of the tag. And that's it. You can yield my state. Now program will require my state. And then you can update the state here. You can read the state. You can do whatever you want. And ultimately, doesn't matter how nested the effects are, as long as you provide the service, as you can see here, my state, they are all going to consume the same stable reference. So as you can see, initialized with 0, and so all of them will start pointing to this state right here. Now in that case, I would recommend using a synchronized ref just to prevent any type of race conditions. Now to wrap things up, I wrote this table comparing the three. So ref is great for a basic mutable reference. It does not have any concurrency safety, and it does not expose a subscription, nor can you make it reactive. You have to do that yourself. Now for use cases, well, when you need simple mutable state, or a single fiber application, or manually managed concurrency. So maybe there are specific concurrency policies that you need to enforce. Well, you can build it upon ref. Now, synchronized ref is a concurrent safe mutable reference. So it does have concurrency safety, as we have seen with a semaphore, a one permit semaphore. It does not expose a reactive solution, so no subscriptions, and well use cases when you have concurrent mutable state. So you share the state in concurrent programs. And finally, we have SubscriptionRef. It is concurrent safe and it exposes a subscription. So it is basically everything that SynchronizedRef has, but it exposes a stream of changes. And when should you use it? When you have or need reactive state, you need to observe changes, or well, in general, when you're building reactive systems. And that's it. I hope you learned something new. I hope I cleared some of your doubts. And if you want to see more content like this, make sure to subscribe. Also, be on the lookout because I'll be releasing a practical course on effect. So make sure to keep your eyes peeled for that, and I'll see you in the next one. See ya.